Hi, today we're looking at 7.7, which is writing exponential functions. Yesterday we kind of focused on graphing. Today we're writing, and there's a lot of word problems. There is a note sheet if you're at home and you'd like to print it out. That way you're not taking up a lot of time writing down all of the examples, because it does make most sense if you can see the whole word problem. So we're going to use these equations to predict for future values, and that's kind of the point. So we got this. All right, and to review from yesterday, what is the graph of the function? If you have matching graphs, like let's say it's multiple choice, you still want to go through and make a little XY table. Either pick the points 0, 1, 2, or -1, 0, 1 is also a good choice. Right? If we plug -1 into the equation, you get 2. If you plug 0 into the equation, you get 4, and then 8. So kind of check and see which of these graphs would that match. All right. This one looks like it would be okay. This one doesn't cross at 0, 4, so it's not that. All right. This one is decreasing, not increasing. So it's not that one. So you can kind of do process of elimination to figure out which graph it is. But the key is still make a table of values. Today we're going to be converting some things from percent to decimal. Right? If you forget how to do that, always divide by 100. So you do your percent divided by 100%. That gives you your decimal answer. So 5% equals 0.05. Some people get mixed up on where the decimal goes. 1.6% is 0.016. All right, so don't always just put them right after the decimal. 25% is 0.25. So divide by 100 to get that decimal form. Exponential growth or decay. This is what you're going to want to write down. All right, your y equals a times b to the power of x is kind of like your equation always. And so initial amount just means your starting value, okay, what you start at. And then you're either going to have 1 plus or 1 minus, whether it's getting bigger or getting smaller, growing or decaying. Here's some examples of graphs from yesterday. But take a moment to write this down, and we're going to use it in the next few problems. So first, you want to take a moment to read the problem. Maybe pause the video. And then we want to look for a few things. All right. In our form, y equals a times b to the power of x, we need to know where we're starting. Okay. So I'm going to first look for the start. Okay. So here is 125 milligrams. That's kind of where we start at. And then we want to decide, is it growing, getting bigger, or is it getting smaller? Growth or decay? And by how much? Okay, so whose concentration decreases, so that's an important piece, by 30%. All right, so it is decaying, so we're going to use 1 minus. We want that percent written as a decimal. So in our equation, we're going to use 0.30. 30 divided by 100. Okay. And we have our equation y equals 125 times 1 minus 0 to the power of x. You could also write it like y equals 125. 1 subtract 0.30 is 0.70 power of x. And then the second piece of the equation is asking how much after 3 hours. So that means when x equals 3. You are going to want to plug that in and get an output. So look for for your start, is it growing or decaying? By what percent, and then how much? So again, take a moment to read it. We're going to go through that same process. So we're going to start with, right, what is our starting value? All right. Since 2005, it has, here's a key piece of information, increased, right, 7%. So that means we have a growth model, and we're going to use 0.07. All right. In 2005, that's the start, right? So here is our start. So we can write an equation from that. Another key piece is what X value are we looking for? So from 2005 to 2015, we're looking for when X equals 10. So there's 10 years from there. My equation will be y equals, here's my start value. It's going to be growth, so 1 plus 0.07 to the power of x. If we want, we can write it like this, 361.07 to the power of x. We're looking for when x equals 10. So we're going to plug that into the equation and get an output. Isn't that much. All right, see if you can do this one on your own. All right, try a couple of these now that we've kind of got the hang of it. Again, these word problems are a little bit longer, but you can go ahead and print it out so you don't have to take it all down. Looking for the start. Okay, suppose the population was this much. Okay, so there's my starting value. And then we want to look for if it's growing or decaying. So my keyword there is grows. All right, so it grows, the growth model. We're going to use 0.015, convert that 1.5 to a decimal. And see for what x value we're looking for. All right. When x equals 25. So from 2000 to 2025, 2025, there's 25 years. So let's start with our equation. The starting calculation, it is growing 0.15 to the power of x. And in fact, in this case, we can just plug in that at 25 and let's get our output right away. Going through, looking for our 3 key pieces of information. All right, what is the start? Here's our start. Right. So go 5, 5. We're gonna see is it growing or decaying. So look for keywords like decreases or increases. All right. So we're gonna use 0.03. 1 minus 0.03. And then what is our x after 10 years? See if you get the same thing. Okay, so we're going to talk a little bit about a bigger equation that has to do with some money, right? And it's kind of cool because this is how some banks calculate your compound interest. All right, I would write down the equation at the start here, and then also label each piece, because if you don't know what the variables mean, it's not going to help you at all to have this written down. All right, so we're going to go through. A is kind of like your y equals. It's the amount that is coming out, or your output. Great. P is your principal, or the starting amount. See, it kind of looks like that 1 plus equation, your growth equation, but there's a little bit more involved with it. All right, R is your rate written as a decimal. Okay, and n is the amount of times it's compounded, right? Number of times compounded. And we're going to talk about this on the next page. And then T is your time, right? Time. So write those ones down. This one's A is kind of like your Y equals. It is your output. So how many times a year is it compounded? So this has to do with that n number of times compounded, right? N. Monthly, how many months are in a year? 12. Quarterly is 4, maybe 4 quarters in a dollar. Semi-annually would be 2, and annually would be 1. So it has to do with that n value and what number to use for the n. All right. Let's go through and take a look at this first example. All right, we need a few pieces of information. All right, we need our starting amount. So if we put $100 in, that's our start. So our P equals 100. Okay. Our rate is 3.5. So our rate, we're going to use 0.035. We want to look to see how much it's compounded. Compounded quarterly means our n is 4. And what is our time when you turn 18? So when you're born till when you turn 18, our time is going to be 18. So now let's fill it into the given equation. So we're looking for our output, and our principal amount is 100. 1 plus 0.035 divided by time of 18. No, compounded down there. Sorry. N to the power of n times time. I like to use parentheses here. And this is, I put the caret key in so that you can see if you're typing it into your calculator, you want to raise it to the power of that. N times time. Yep. N times time. So 4 times 18. Okay. The most common errors with this type of problem is typing it into your calculator wrong. So please take a moment and try to match what I get. All right. 1 plus 0.035 divided by 4 to the power of, and please use parentheses, otherwise you're going to end up getting the wrong answer. $87.247, but we'll round that to 25. It's funny. All right, so this is multiplication in here. If you want, you can just think like parentheses around that 4 times 18, right? That is multiplication. So check with your original equation here. That it's raised to the power of n times t. Okay? So let's do one more. I'll shrink this so that you can get a little bit more space to work. We're going to look for a few different pieces here. My starting amount, we received 750, so that's going to be my first value, right? My rate, I'm going to use 0.0425, right? It is always growing with money, 0.0425. Over n, how much is it compounded? Semi-annually, we're going to use 2. And to the power of, so it'd be n times time. So 2 times, and my time is 4 years. So 2 times 4. All right, 2 times 4 is 8. So you have